G'day, Bruce here, and welcome to another edition of Scripting Adventure. We're continuing the series on creating a fully parametric custom door in GDL. In the last episode, we started scripting the leaf outer frame with nice rounded corners and a hole in the middle also with rounded corners. In this episode, we'll script the glazing bars and the glazing panel in the middle. Now I'll show you how to script a circular prism with a circular hole. And I also show you how to use the CUTPOLYA command to cut geometry using a circular shape. We also script the indicator light at the top of the door. What now? Let's deal with this middle bit. We need to define the diameter. So let's put in here, let's just call it glazing bar diameter 650. Now I want this to be drawn as part of my leaf. So I'll put this delete right before the return. So I'm down here. I want to come up to the center of my leaf and across to the center of my leaf, center, center. So let's create another variable called leaf height, which will be b minus my frame width twice. That'll give me my leaf height. When we go add, we want to add in the x and in the y. So we'll just put in an add and we'll go minus, and y is half the leaf height plus GS frame width. Now an add needs an x, a y and a z. We do nothing in the z. We need to make sure we delete that to bring our cursor back down to here. When we're finished, we want a prism number. We want 3 coordinate points for a prism with a hole in it. The height will be, I'll define my center point, define my outer radius, which is glazing bar diameter divided by 2. That's my radius, 360 degrees, and status code of 4015 plus 64. My inner radius will be divided by 2 minus my leaf frame width. And again, 360. Let's just try 4000, see what happens. I need to put on a surface. So this one needs to be 915 plus 64. There we go. That gives me my surface. My glazing bar circle. Now I need to draw this bar through the middle. And this is going to be interesting because of the curve here and the variability with the GS resolve changing the segmentation. So I want to make my life easy. So I'm going to do it in a different manner. I'm going to employ a slightly different strategy for this one. It's my horizontal glazing bar. Now at the moment, my cursor is sitting right in the middle here. So I'll just draw a prism from there across to there, which will be 4 points. 1, 2, 3, 4. I can just copy that prism statement down, change it to 4 coordinates, and it will be minus. So that's here in the X, and in the Y it will be, and this will just be a 15. No smoothing for this one. And plus. This will be plus, and then back to this side, and that'll be plus. Let's see what happens there. There it is. Now what I'll do to get rid of the center portion is I'll use a CUTPOLYA. A CUTPOLYA you'll find under 3D shapes, cutting in 3D, CUTPOLYA. I've previously covered cut plane in a previous video. Again, link it up there and down there. We want CUTPOLYA this time. Whereas a cut plane will just do a plane, a CUTPOLYA is like a prism that cuts. So it's the same sort of thinking. And we've got the number of base coordinate lines, we've got the status, we've got the distance, and then we've got our coordinate statements. I've just flicked over to the online version because it doesn't split across pages. So it's superior, the CUTPOLYA is superior to the CUTPOLY command because the cut poly command doesn't have status codes. And without status codes, you can't do curved shapes. CUTPOLYA, we're introducing our masks, which means we can now curve like so. So the status is 1 uses the attributes of the body. That's what we'll do. Keep it simple. D is the distance between the local origin. And so we'll just use 0, just cuts with an infinite tube. And the mask is similar to the prism command. And we know what those are. So you declare your cut plane, cut poly, cut command before the geometry you want to cut. So we'll go CUTPOLYA. It's thrown in a cut end here. And we want that cut end after our geometry statement. So you establish your cutting plane or your cutting body, declare the geometry you want cut, and then put in a cut end. It will be just a circle, so it'll be a circle to match this. And so that only needs 2 lines. It'll be a status of 1, a distance of 0, and then we declare our coordinate lines. These statements, statement 1, ... statement n, that just refers to the geometry. It's a little bit confusing, but that's all it means. So now we're putting in our coordinate lines. Remember, my cursor's in the middle still. We'll go CUTPOLYA 0, 0, declaring my center point. We'll just make it 915, and then it's this one. Glazing bar diameter. Declare this, and then a cut end. Let's see what happens. Here we go. It's cut my glazing bars. We're getting lines between them, but I'll do that later on. Let's do the glass now. For simplicity, we'll just set the glass in the middle of our leaf thickness. So that delete is part of this here. So we've returned our cursor down to this point, and now we can draw our glass. So I'll just start by drawing it as a single plane to show you what happens. Let's just change this. We don't have a panel surface. That should be a Boolean. Panel beam at override. All right, panel surface. Need to indent that so it appears in that menu. Same with this one. So set our material. Given that that is the same as that, I don't think I need to declare that again. Just setting the material and the surface. Now we've already worked out the coordinates of all this inner hole here. So which is all this, right? Down to there. So we'll just put them into our coordinates, into our buffer. Get rid of this last comma. And then I can put in my prism. How thick is my glass? I don't have one, but I can create one. And I know that's called GS glass thick. You can find these out by opening a Graphisoft door. Just checking out what parameters they use. Indent that as well, so it appears in that menu, glass thick. Now I've been a little bit lazy here for this demonstration. A door panel is actually a solid panel. I should have created glass materials for the vision panels for the glass, but you get the point. So GS glass thick. And what we want to do before we draw this, we want to add in our Z direction. So at the moment we're at the external face. We want to add half of our leaf thickness, which is GS leaf thick. And then we want to come back half of our glass thick. And then when we've finished that, we want to delete 2. We can put that delete down there. Let's see what happens now. There's our glass. Now, by drawing a single pane like that, I've got clashing geometry here. I can go to the trouble of drawing individual panes for all this. You can accept that that's okay to do it like that. You can do a group to subtract one from the other. You can run a cut poly in the same position as the plane to cut this leaf, cut the glazing bars of the leaf, but for now I'll just leave it like that. Now you might be wondering, why did I just copy and paste the coordinates for the glass down? Why didn't I utilize the buffer coordinates that are already there when I advocate for using the buffer? And the reason is that we have both outer coordinates and inner coordinates sitting in the buffer, and I'm only after the inner coordinates. And there's no real simple, quick and easy way to extract one from the other. And there are strategies that you can employ to do that, but that's a lesson for another day. And we'll just put in our indicator light as well. Just created a quick subroutine. Copy my building material statements down. I'm not going to change the pen. The pen can stay as it is. The light building material. So I've set my building material and my surface if it's overridden, so it doesn't inherit the default building material. And I want to come up to the center of here and draw my light. So what's that? Add Y. And we're in the middle now. Our cursor's here because we've reset it down here, so it's back in the middle. We just want to come straight up. Our B height minus our frame width plus half that distance. And we've done that calculation before. Up here with the indicator hole. Now I could just use those as coordinates in my prism command, but my personal preference is to move the cursor where you need it to be to draw your prism. It makes working stuff out a bit easier. So we add Y and we draw our prism. We have 2 coordinate lines. It'll be, let's make it 5 mils either side of the frame thick. And that will be our indicator there. Let's delete one. I actually want to add in the Z as well, the 5 mil to recess the indicator back from the face. So we'll take that off and make it an add. So 0 in the X, that far in the Y, and then 5 millimeters. All right, let's see what that looks like. Not enough parameters. Right, I forgot my comma just there. And there's my indicator light. Set back. Now if I want to check that that's drawing correctly, because I don't think it is, I can just comment out these other subs. Go subs like that. I'll just have my light. There it is. Doesn't have its sides. Right, there's my indicator. Very good. Turn these back on. Excellent. Remember we put in this Boolean indicator on. So under my subroutine, I can go if indicator on. Now, when you're doing an if statement with a go sub, you don't need a then. That statement will work. If indicator on, go sub indicator. Whereas down here, if indicator on, because it's not a go sub, I needed a then. So let's turn that off. Disappears. Turn it on. It's back. Excellent. We'll wrap this one up there. Now you know how to model a circular prism with a circular hole in it, and also how to cut geometry with a circular shape using the CUTPOLYA command. In the next episode, I cover the complexities of removing unwanted lines between adjacent geometries and how to keep wanted lines between adjacent geometries using the body -1 command and the model wire command combined with the right status codes. I'll see you there.